Of all the forces that govern our universe, none is more mysterious or relentless than time. It marches forward, carrying us from the past, through the present, and into the future, and for as long as we've been aware of it, we have dreamed of breaking free from its grasp, to revisit the past or to leap into the future. But is this just a fantasy? Or could the laws of physics as we know them actually allow for a time machine? First, we need to understand what time is. For a long time, we thought of it as absolute, a universal clock ticking at the same rate for everyone. But then, our understanding was revolutionized. Space and time were not separate, but a single, four-dimensional fabric, space-time. This fabric is not rigid. It can be bent and warped by mass and energy. So, how do we travel in time? Well, in a way, you are doing it right now. We are all traveling into the future at a rate of 1 second per second. But can we change the speed? The answer, surprisingly, is yes. Welcome to time dilation. The faster you move through space, the slower you move through time relative to a stationary observer. If you flew near the speed of light for a few hours, you would return to find decades or even centuries had passed on Earth. This isn't science fiction, it's a proven consequence of special relativity. You have traveled into the future. There's another way. Gravity also warps time. The stronger the gravity, the slower time flows. Spending time near a supermassive object like a black hole would have the same effect. You'd be a time traveler. So, traveling to the future is physically possible, though technologically far beyond our reach. But what about the past? This is where things get truly complicated and strange. Traveling to the past seems to violate a fundamental principle of the universe: causality. Effects must always follow their causes. A shattered glass doesn't spontaneously reassemble. To go back, we would need to find or build a closed time-like curve, a path through space-time that leads back to its starting point. One hypothetical way is a traversable wormhole. By accelerating one end to near light speed, you could create a time difference between the two mouths. Step into the future end, and you could emerge from the past end. You've made a time machine. But there's a problem. Wormholes, if they exist, would likely be incredibly unstable and collapse instantly. To keep one open would require exotic matter, a substance with negative energy density, which we have never observed. Another idea is the Tipler cylinder, a massive, infinitely long cylinder spinning at an incredible rate. The spinning would drag space-time with it, and a specific path around the cylinder could be a closed time-like curve. The catch? It would need to be infinitely long and impossibly dense. Not exactly practical. All known theories for traveling to the past require manipulating objects with the mass of stars or energy of entire galaxies. But even if we could overcome the engineering, we face an even bigger problem: paradoxes. Meet the most famous one, the grandfather paradox. What if you went back in time and prevented your grandparents from meeting? If they never meet, you are never born. If you are never born, you could never go back to stop them. A logical contradiction. Then there's the bootstrap paradox. Imagine a time traveler gives a famous playwright a copy of his own future work. The playwright just copies it. The question is, who actually wrote the play? The information exists in a loop, created from nothing. These paradoxes are so serious that some physicists believe they are impossible. The universe must have a way to protect causality. One idea is the Novikov self-consistency principle. It states that any event in a closed time-like curve must be consistent with the rest of history. In short, you can't change the past because you are part of the past. You can participate, but you can't alter the outcome. Another solution is the many-worlds interpretation. When you go back and change something, you don't alter your own past. Instead, you create a new, parallel universe. Your own timeline remains safe, but you are now a refugee in a different history. So, where does this leave us? Traveling to the future seems plausible, a matter of extreme engineering, but traveling to the past is blocked by paradoxes and physical impossibilities at every turn. One famous physicist even proposed a chronology protection conjecture that the laws of physics are conspired to prevent time travel to the past. The simplest evidence against past time travel is that we haven't been overrun by tourists from the future. However, our understanding is incomplete. We don't have a theory of quantum gravity, which could reveal new, stranger rules about space-time. Perhaps in that final theory a loophole exists. For now, a true time machine remains firmly in the realm of fiction. But perhaps we already have the only time machines we'll ever need: memory to visit the past, and dreams to explore the future. And the most important place to be is right here, right now, in the ever-unfolding present. The universe seems to have a clear direction. Causes precede effects. This is the arrow of time. This is often tied to entropy, the measure of disorder, which always tends to increase in a closed system. To reverse time would be to decrease entropy on a massive scale, something that seems forbidden by the second law of thermodynamics. Your path through space-time is called your world line. To travel in time is to bend that world line. Traveling near the speed of light tilts your world line more towards the space dimensions and less towards the time dimension. But to go to the past, you need to bend your world line into a loop, a closed time-like curve. Theoretically, a spinning black hole could create such curves through a process called frame dragging. However, entering this region and surviving, let alone navigating a path to the past, seems physically impossible for matter. Another highly speculative idea involves cosmic strings, theoretical defects in space-time left over from the early universe. Like exotic matter, there is currently no evidence that cosmic strings even exist, so all our best ideas for travel into the past rely on things that might not be real or are impossible to build. This has led many to believe that causality is a fundamental, unbreakable law. One way around paradoxes could be that you can travel to the past, but you can't interact with it. You would be a phantom, unable to alter the events that have already transpired. The many worlds hypothesis is perhaps the most elegant solution, as it preserves causality within each branch, but it also means you can never truly go back home. You can only travel to an alternate past. Let's not forget the energy cost. Creating curvatures in space-time sufficient for time travel would require unimaginable power. And in the case of wormholes, it might require a type of energy that breaks the known laws of physics. Some physicists speculate that at the quantum level, space-time is a chaotic foam where causality is briefly violated. But scaling one of these up to macroscopic size would, again, require impossible amounts of energy. Ultimately, a final answer likely awaits a complete theory of quantum gravity. So, while we can't rule it out completely, the barriers to building a time machine seem immense. Perhaps our descendants will solve these problems and one day visit us. Or perhaps the universe has locked the door to the past for a very good reason. Fun fact, time dilation is a real-world engineering problem. GPS satellites have to account for both special and general relativity to work correctly. Their clocks run faster in lower gravity, but slower due to their high speed. The net effect is that they get ahead of Earth clocks. So, in a small way, we all use the principles of time travel every day. The issue with changing the past is that the ripples of your actions would change everything. Even the smallest change could have monumental, unpredictable consequences for the future. Our physics is a story of discovery. What seems impossible today might be understood tomorrow. A theory that unifies the very large and the very small could rewrite our understanding of time itself. Perhaps the impossibility of time travel is what gives our lives meaning. Our choices are final, our actions have consequences, and the time we have is finite and precious. We can't change the past, but we can learn from it. We can't know the future, but we can work to build a better one. And in the end, the most profound journey is the one we take through our own unique timeline. The question of time travel forces us to confront the very nature of reality, choice, and existence. Whether we can ever control it or not, time shapes every aspect of our lives. The arrow of time points firmly forward, a fundamental feature of our universe. From the smallest particles to the largest galaxies, everything is on a journey through time. The mathematics of relativity doesn't explicitly forbid time travel, but the solutions that allow it seem physically absurd. It's as if the universe has safeguards in place, making any attempt to violate causality incredibly fragile. Self-consistency demands that you can't create a past that didn't happen, only fulfill the one that did. This would mean that any time travelers in our past are already part of our history, their actions already accounted for. The many-worlds view is perhaps the most mind-bending. Every quantum event creates a new universe. In this multiverse, everything that can happen does happen, just in a different branch. So, to recap, hopping a few decades into the future? Plausible. Revisiting last Tuesday? Almost certainly impossible. The silence from our future descendants is a powerful, if circumstantial, piece of evidence. But science is a process of filling in the gaps. We must remain open to new discoveries. Until then, the human mind remains the most powerful time machine we have. It allows us to learn from our yesterday and plan for our tomorrow, all from the safety of today. The quest to understand time is one of the greatest adventures in science. And it's a journey that is far from over. So, time travel to the future is possible through speed and gravity, but traveling to the past is plagued by paradoxes and seems forbidden. The universe seems to allow one-way tickets to the future, but round trips are not on the itinerary. The law of causality, that effects must follow causes, is one of the most robust principles in all of physics. Violating it would unravel the logical structure of the universe as we understand it. Perhaps the most profound takeaway is the value of the present. Our actions today are the seeds of the world we will inhabit tomorrow. The dream of time travel has inspired countless stories and pushed the boundaries of scientific imagination. It forces us to engage with the deepest and most beautiful theories we have about our cosmos, and it reminds us that there is still so much we don't know. The edge of our knowledge is where the most exciting adventures begin. We are all travelers on a cosmic journey, made of stardust, bound by time. The universe is a beautiful and intricate place, and the quest to understand it is a noble one. Science is a collaborative effort, a story told across generations. Each generation builds upon the last, reaching for a deeper understanding of our reality. So, while a time machine may remain a dream, the journey to ask the question reveals the beauty of the universe we are in. The story of time is the story of everything. Thank you for joining us on this journey through space-time. Your curiosity makes these explorations possible. If you enjoyed this journey through the fabric of reality, consider subscribing to our channel, Capybrain, for more adventures into the biggest questions of science. Don't forget to ring the bell to be notified every time we explore a new cosmic mystery. We have so many more questions to answer together. From all of us here at Capybrain, stay curious.